to do the data collection and analyze step. And we will separate this part into the collection of data and the analysis of the data. In the data collection process, the information concerning the risk factors may be obtained from medical, occupational, or other records, and which can avoid some reporting bias. And the interviews and questionnaires are the most common means of determining a subject's exposure history. Interviews can be conducted face-to-face or by telephone. To ensure that information from cases and controls is obtained in the same manner, interviews should be standardized, monitored, and conducted by trained interviewers. Interviews are useful for collecting data because questions may cover a wide range of potential risk factors, and the costs are relatively low, and the information of the exposure that occurred years prior to the onset of the illness can be obtained. Occasionally, there is a concern that cases and controls may record exposures differently, perhaps distorting the case-control comparisons. For example, cases perhaps in an attempt to explain their illness may over-report exposures. This is of particular concern when there has been a great deal of publicity about the association between the exposure and the disease of interest. For example, after the association of smoking and lung cancer study was first identified and published, knowledge of this association could have affected the reported exposure of cases in subsequent investigations. The most objective means of characterizing exposure is through the use of biological marker in blood or other specimens. There are several difficulties inherent in the use of biological markers. However, obtaining the specimens can involve an invasive procedure that discourages subject participation. Second, many diseases do not have known biological markers. Third, even if a marker exists, it may be transient and thus not present when the measurement is taken. Finally, the disease status may alert the metabolism, thereby distorting the case control comparison. So, after we collect the data, we can now sort the data into this type of figures, and then we can start the analysis of the data. We can see that we can from the cases and the controls and subdivided them according to whether they have exposed or unexposed to the exposure. And the next step is to sort the data and into this kind of tables, which is listed by number of cases and controls according to whether they were exposed to some exposure. And this is a kind of sorting of the data using that unmatched analysis, which is an unmatched case control study. And in this kind of study, we will use the chi-square test to test whether the exposure to the exposed is different between the cases and controls. After we test the difference between the proportion of the exposure among the cases and controls, we know that they are different from each other. But how to estimate the magnitude of this difference? Not like that in the cohort study, in case control studies, the relative risk is not able to calculate because no incidence of the disease is available. So we cannot use the relative risk to assess the effect size of the association between the exposure and the outcome. And another very useful measure of the association of exposure and outcome is odds ratio. So what is odds ratio? The odds refers to the probability of an event occurring relative to that is not occurring. For example, among the 100 lung cancer cases, 70 of them are smoker and 30 are non-smoker. we might say the odds of smoking are 7 to 3. In the case control study, the odds ratio is the ratio of the odds of the exposure among cases to the odds of exposure among the controls. That is the odds divided by the odds. That's called a ratio. So if the odds ratio is 1, then the exposure is not related to the disease. While the odds ratio larger than 1, that means the exposure was positively related to the disease, and odds ratio less than 1 means the exposure is negatively related to the disease. And this slide shows how the odds ratio was calculated. So we can see that the odds ratio is divided through the odds of case exposures to the odds of control exposures. And according to the table that we have seen in the last two slides, we can see that it equals to AD divided by BC. And there are two ways of estimate for the confidence interval for the odds ratio. As we have previously learned from our statistics courses, for the estimation of a variable, we can use a point estimation and also an interval estimation. So odds ratio is a point estimation, while we usually have an interval estimation considered as the confidence interval for the odds ratio. One approach is listed in this slide, and which is according to the chi-square test result. Another is in this slide, which shows the Wolf's method, and we can see that because of this kind of sampling error, this interval estimation can be estimated through two different types of methods. And then nowadays, there are many softwares in the computer, and we rarely use these estimations from the Wolf's method or the methods in last slide. We rather calculate them through the softwares. For example, let's take again the example between for the association between smoking and lung cancer. Here we can use chi-square test to show the association between smoking and lung cancer. And in the chi-square test, the value of the chi-square is 19, and with the degree of freedom 1, and we can see that the p-value is less than 0.01, so that we can confirm that there's some association between lung cancer and smoking. When we want to estimate the effect size of the smoking on lung cancer, and we can then estimate the odds ratio. So we can see from this table that the odds ratio can be calculated by AD divided by BC. And the final odds ratio is 2.97. So the odds ratio of smoking among the lung cancer patients were about 9 times greater than the odds of the smoking among the controls. As the more odds depart from the 1, the greater the association between the exposure and the outcome. So then the odds ratio can be interpreted in two ways. We could say that the odds of smoking are 3 times greater than those with lung cancer compared to those without lung cancer. This interpretation is based on a comparison of the exposure odds of case group and control group. Alternatively, we also could say that the odds of lung cancer are 3 times greater than among the subjects with the history of smoking compared to those people without smoking history. This interpretation is based on a comparison of the disease odds among the exposed and unexposed relative respectively. Since the derived formula for the odds ratio, AD divided by BC, is the same whether the exposure odds or disease odds are used, either interpretation is acceptable. As we previously have mentioned, that in a case control study, only the odds ratios can be calculated as a measurement of the association. While in a cohort study, either the relative risk or odds ratio is a valid measure of the association. But generally, the people like to use relative risk as a measure of the association in the cohort study. Even if the odds ratio is used as a measure, people like to how well it approximates the relative risk. Once some books or journals have called the odds ratio a relative risk. Can we use the odds ratio to estimate the relative risk? When the cases studied are representative of all people with disease in the population from which the cases were obtained, then we can use the odds ratio to estimate the relative risk. And also, we need the controls studied are representative of all people without the disease in the population from which the controls were obtained. And we also need the assumption that the incidence rate of the disease being studied is very low, so that the odds ratio will approximate the relative risk and the rates ratio. In the previous slides, we are mainly talk about the unmatched case control studies. Now we can take a look at the matched case control studies. So in a matched case control study, this kind of analysis for the data is called the matched pair analysis. Let's take for one control as an example. And the data can be expressed in a fourfold table, and the number of concordant and discordant pairs are calculated. So in this kind of matched case control study, the test for this analysis is McNemar's chi-square test. And the following table is the fourfold table that we need to assemble the data. And in this kind of paired analysis, as we mentioned that the test for the association was the McNemar chi-square test, which is calculated as the B plus C with the square and divided by D minus C. And while the odds ratio for the association could be defined as calculated as C divided by B. Now let's still take a look at the matched case control study on smoking and lung cancer. And this table shows the matched pairs of the cases and controls according to Down and Hill study previously. So therefore, the chi-square test that tests the association between smoking and cancer can be shown in this slide with the McNemar chi-square test, and the result shows that the p-value is less than 0.01. Well, when we calculate the odds ratio, it is calculated as C divided by B, and which results to an odds ratio of 8.7. And we then also estimate the confidence interval for this odds ratio.